Okay, we're going to do some SAT problems here. These are just some selected SAT problems. And so here we go. Let's do this one. You've got a circle. EF is a diameter, and G lies on the point of the circle. And what we've done, we've made a triangle right here. So here's your diameter. I've connected E to G and G to F. This is the way that it looks in the book. And the main thing that you have to understand here is that when you have this is called an inscribed angle. So from geometry, you can look this up under the circle chapter. And this is an inscribed angle. If an inscribed angle cuts off a semicircle, so it goes to E, which is right here, and it goes to F, which is right here, and look at that arc that it forms. It forms half a circle because this is a diameter. So if I go from any point, actually, any point on this, anywhere actually on the circle, but we'll just talk about this semicircle up here. Any point up here, if it's drawn to the ends of the diameter, what we say is it cuts off a semicircle. And if you remember anything about inscribed angles are half of the arc that it cuts off. Well, this bottom EF right here, I won't put another point here, but this bottom arc EF is a semicircle. It's 180 degrees. So the inscribed angle is half of 180 degrees, or that would be 90 degrees. So the important thing here is to understand that this is a right angle. Now, if you understand that this is a right angle, let's put some stuff in here that we know. And let's just do this in a different color here. Alright, so EF is 17, so this whole thing is 17. This side right here, that's the hypotenuse of the right triangle. EG, which is this side right here, which is x plus 5, is right there, and then GF is x minus 2. So this little segment right here is x minus 2. And what we're trying to do is we're trying to solve for x. Well, again, like I said, the key is to understand this is a right angle, this is a right triangle. So now what I can do is I can just do Pythagorean Theorem. Let's see what we get here. Let's scooch this down a little bit. So this is our hypotenuse. So these are our two legs. So I square the two legs. So let's make that look more like a plus. There we go. So I take the two legs, I square them, add them up. That equals the hypotenuse squared. Okay, that's just straight up Pythagorean Theorem. Now we have to do a little bit of algebra here, and let's see what we can do. We have to we got to FOIL this thing or distribute it, however you want to say it. It's a perfect square. So there are rules for perfect squares. We'll just do it real quick here. This is going to be x squared plus, if you take this and you add it to itself, where you multiply by 2, either way, it's a 10x. Then you multiply it by itself, and it's 25. So that's how you multiply a perfect square, or how you square something like this. I won't go through all the little details on this. So this is x squared minus 4x plus 4. You could always multiply them out. Now remember, it's not x squared plus 5 squared, so it's not x squared plus 25. You've got to take this, multiply by itself. That's what squaring is, and then you'll get this thing right here. Same thing for this, and that equals, that's 289. Alright, so let's see what we can do here. Let's try to solve for x. So I've got x squared plus x squared, which is 2x squared. I like to mark those off once I'm done with them. I got 10x minus 4x, which is plus 6x. Done with those. And then 25 and 4 is 29, equals 289. Now this looks like a quadratic, so let's do this. Let's subtract 289 from both sides. So I've got 2x squared plus 6x. Now if I subtract 289, or actually, let's do it like this. It's a little easier. That's a 6, 0, so it's 260. So it's 260 over here on the right-hand side, but let's move it to the left. It would be minus 260, and that would equal 0. With a quadratic, we always want to set it equal to 0. Now, we could solve for it just like this. You could try to factor it the way it is. You could use Pythagorean Theorem. You could use completing the square. There's all kinds of options. What I would do is I see that I have a 2 in common with both of these. I think that might make my numbers a little smaller, make it a little easier to deal with. You don't have to do it this way, but I think it works kind of nice. Divide everything by 2. So that's an x squared, that's a 3x, and that's a minus 130 equals 0. This is a little bit easier to work with. Now don't take too long on this, especially on the SAT, because it is timed. You could just throw it into the not Pythagorean Theorem, what's it called? The, oh my gosh, I just said it like 2 seconds ago. The quadratic formula. Wow. Anyway, you could put it in the quadratic formula. You could do that and that would work. It'd be fine. I think that's a little tougher. If you look at this, this does actually factor pretty easy, so it's a little easier to factor it. So what multiplies to be negative 130 and adds up to be 3? Well, 13 and 10 work, so it would be positive 13 and a negative 10. All right, so whatever is best for you. So it's going to be a positive 13 and a negative 10. All right, so it multiplies to be negative 130, adds up to be a positive 3, and that's factored. Set these both equal to 0. So if I set this equal to 0, I get x equals negative 13. And if I set this equal to 0, I have x is equal to 10. All right, and what I'm going to do is I'm going to keep 10 because if you look at this, if it was negative 13, look, if I put a negative 13 in for this, I would get a negative length. Negative 13 plus 8 or 5 is negative 8. You can't have a negative 8 length, so I'm going to just not even consider negative 13 as being one of my answers. So I use x is equal to 10, and that is letter D in our multiple choice. Okay, here's another one. This is number 14. I know it's not exactly in order, but that's okay. What we're going to do here is let me just read some things about this. You got 3 circles, obviously. Each circle has a radius of 4. So all of these circles have a radius of 4. Let's put that up here. Okay, so the radius is 4 for all those circles. A, E, and D are the centers of all these circles. Okay, so the circle on the left, the center A, the circle in the middle, circle E, circle on the right, circle D. So those are their centers. It says 2 circles are tangent at point E. So this circle A and the circle D are both tangent, which means they just hit each other at one point, which is at point E. So they just touch each other at that one point. And the circles intersect at B and C. Okay, obviously they intersect it right here and right here. Okay, it says here's the question. What is the perimeter? All right, so let's write this up here. What is the perimeter of ABCD? So it's a quadrilateral, ABCD. Put a little question mark there. That's what we're trying to find. So ABCD. So what we're going to do, it's a 4-sided figure, so what we're going to do is we're going to draw it. So let's go A to B. Oops, sorry about that. A to B, B to C. Try to make that straight. Okay, to D, and then to close this off, we'll go back to A, like that. All right, so that's what we're trying to find right there. We're trying to find the perimeter. So what we're going to do is find all the lengths of those 3 sides right there. Alright, so remember this is a key right here is the radius of the circle is 4. So let's take a look at one of the sides. Look at AB. Well, AB is actually the radius of this circle A. So that would be, we'll put it right here. So that would be 4. Look at AE. AE would be 4 as well. Look at DE. That's also radius of this circle D. So that's 4 because the radius for all 3 of these circles is 4. DC is 4 as well. So that was pretty easy so far. But here's the key. BC, that's the hardest part about this. It's not necessarily the radius of one of these circles, but maybe it is, maybe it isn't. Here's what I did. I put a couple extra lines in here to help me out. There could be another way to do this. I'm not sure exactly the best way to do it, but this is how I figured it out. So what I did is I kind of like triangles. So I connected B to E and I connected C to E. Right, let's see how that helps. Let's see what we have. Okay, here's the part I got stuck on when I first did this. Was finding the length of BE. For some reason, I just didn't see that center circle. I keep looking at these 2 end circles, okay, because that's how we found these other 2 radii. I don't know, I just kind of lost track of that center circle. So the ones I did in pink or magenta or whatever this color is, BE, if you look at it, it goes from E of the center of the middle circle, and it goes to the end of the circle. So that's a radius as well. So that has to be 4, and that has to be 4 right there. So that helps out a little bit. Still, I have to find what BC is. Now, you know, you could kind of make some assumptions. These look like 4, 4, 4. This looks 4, 4, 4, so that must be. But I couldn't think of a good reason for that. So what I did was this. I saw that this was equilateral triangle. So an equilateral triangle is also equiangular. So that's 60, that's 60, and that's 60 right there. Okay, same thing with this triangle. 60, 60, and 60. Let's see. What am I trying to do, really? What I'm trying to do is find out if this really is equilateral or not. Alright, so I don't know of any theorem that makes that equilateral, so what I did is I went with the angles. So what I want to try to do is find the angles of these 3 angles in this side of the triangle. Well, let's do this middle one down in here. Look, if this is 60 and this is 60, that whole thing makes 180. So If this is 60 and 60, that's 120. Take it away from 180, and that's 60 right there. All right, so that's pretty good. So you could look at it a couple ways. If this is 60, these two sides we know are equal to each other, so these two angles must be equal to each other as well. So if this is 60, these two must add up to 120. If they're equal to each other, we just split it in half, and so we get 60. Hope that didn't confuse you too much. There's a couple other ways you could do it as well. If you have a this is an isosceles trapezoid, and we also know something about an isosceles trapezoid, that the base angles are supplementary. So if this is 60 right here, then this angle has got to be 120. Remember where I said that the base angles are supplementary, so they have to add up to 180. So if that's 60, that has to be 120. We already knew that this one was 60, so in order for it to be 120, that has to be 60 as well. You can do the same thing over there. Alright, so there's all kinds of ways you could figure that out. Now, look at this triangle. It's 60, 60, 60, which means it's equiangular. If it's equiangular, it's equilateral, which means this side BC must also equal 4. That's the key. Finding the perimeter is really not the big deal. Finding what BC is equal to is the big deal. So let's see what we got. We got a 4 here, 4 here. What do we got? We got 1, 2, 3, 4, 5 of them. 5 times 4 is 20, so the perimeter is 20. And that would be answer B.